In this video, we are talking about how to add two vector quantities. The scalar quantities can be added directly, like 5 plus 3, these are scalar, so you can simply write 8, or 4 plus 2 plus 1, it would be give you 7. But in vector, we cannot add the magnitude directly. The vector, the scalar quantity have magnitude only. That's why we can add them directly. But vector have both magnitude and direction, so we cannot add them directly. Now I'm going to show you how to add two vectors. Suppose I will give some examples how to add vectors. Suppose I will make a simple direction compass. It's north, south, east, west. Suppose we have given a vector A. This is suppose vector A. It have 2 units to the east, and the other vector B is given it's 2 unit, it's 3 units, so its magnitude, the magnitude of A is simply 2 units. The magnitude of B is simply 3 units, but they are in the same direction. If the vectors are in the same direction, we can add them like scalars. So the resultant vector will be, if we add this one, the resultant vector will be this vector C, and 2 units of this one added to 3 units of this one, so its magnitude will become 5 units. But the direction is the same as east, west to east, or we can say 0 degree to the east. Okay, I will make slightly complicated this one. If now this one is A again, this is to the 2 unit east, but now I will make a vector B, which is at certain angle. Suppose I will take a random angle. Suppose this angle is now here is 45, but actually I will this angle, this is vector B, this one still have the same. Let its magnitude is the same as vector I will draw a vector suppose of the same length as B, 3 unit, but now it's making an angle theta with the direction of A. Now how to add these two vectors? You cannot add like previous, it's 2 and 3 5 to the east. Now the direction is different, so you cannot add this vector directly. Now you need I mean you can add them you can add them using different method. Now here I'm going to show you the two methods. Like if you have this types of graph, you can add these two vectors graphically. So to add these two vectors, I will just copy this vector b. Okay, I will just okay I will this is vector b, and another vector I will put vector a starting from this point. This one is the vector, oh sorry, I cannot put this vector like this. Okay, so I need to put another vector like this is vector a. So remember, one vector should be the tip of another vector, because we are going to add. So you need to put one vector and a bottom of one vector in the tip of another vector, or you can put you can put if you just this is b, or you can put a in the top of like this. This is a, and the third component, the third side of this triangle, here to here, or you are going for a, you are going from this point to this point, and for b you are going from this point to this point, this point to this point. For a you are going from here to here. In actual you are going from this point to this point. And now you can measure the length of this one, and you can measure the angle. Suppose this angle is now let me denote it angle by phi. So you can say the magnitude of the resultant vector c, that is a plus b, vector a plus vector b. This one is the magnitude you need to measure with your scale, and this is the direction. Here you can define direction in different way. If you want to say certain degree to the east, you need to measure this angle, how much this is making with this east direction. Or if you want to say it, you need to take a reference point, a reference line. If you want to take this reference line, then you need to measure this angle. If you want to take this b as a reference, so you need to measure this angle. Or you can do same thing here, just you need to measure this is the c, that gives a plus b, and you can measure this angle. This is not theta now, this is b, another angle, this may be another phi. This is graphical way, so just put one vector in the top of another vector. And remember that doing this, you do not need to change this angle. You have to keep this angle, so that you can see in here this. If you consider this line as horizontal, so this is making 0 and this is making theta. So use the same thing here or same thing here to measure the vector, to measure to add two vectors. So this is graphic way. So now I'm going to show you another way. This is the quite general way to calculate to add two vectors. So here is one vector, 2 units. This is vector A, and here is another vector, it's 3 units. This is the vector B, and this is making at certain angle theta. Now you need to resolve these two vectors. The vector resolution, if you don't know how to resolve, then I will make a separate video where you can see how you can resolve a vector into x and y components. So it's already in x components, so I do not need to resolve this one. This one have 0 y component. So for this vector, the x component is a. I will just take magnitude of a. This a is the magnitude of vector a, and the y component is 0. And for this vector, the x component is this, making theta with x direction, so it's simply b cos theta, and y is b sin theta. How to resolve this one? So always remember one thing: the adjacent side which makes an angle, that will becomes cos, and the other side is sine. So this is y component and this one is x component. Similarly, it only have x component. Now we need to add x component and y component. Let the final vector will let's suppose the final vector is c. So c is the vector that will given by, that is result of a plus b. So now the x component of c is x component of a plus x component of b, which gives me it have just a plus b cos theta, and the y component of c, ay plus by, so it's just b sine of theta. Okay, so now what is the magnitude? So I'm denoting this magnitude of c by just c. So this is given by square root of x component of c plus y component of c. Now you can just square this one, a plus b cos theta square plus b sin theta square. So this will gives you the magnitude of c. Now you need to find out the direction. So direction of c is given by, so yeah, if you complete this figure then it's more clear. So okay, now this one is vector a, this one is vector b, this is c. Now this length is given by, this is angle theta, this length is given by square root of a plus b cos theta plus b sin theta. This is b, this is a. But now we need to find out the angle. So here I'm going to find out to find, I'm going to find this angle. Suppose this angle should be a phi. Now you can see from my geometry, so this side and this side. Okay, let me use good color so that you can see clearly what's going on. So you, if I just increase this one and this one, so this component is this component is just x component of a. From here to here it's x component of a, and from here to here it's x component of b, and from here to here it's just y component of b. So if you calculate tan phi in this large triangle, so if I named triangle R S T, in the triangle R S T, so tan phi is perpendicular by base, so it's just by divided by ax plus bx. Now you need to just replace the value of by. By is b sine theta divided by ax is simply a plus b cos theta. This is tan phi, and you need to find out angle phi. So this is tan inverse of this value. Okay, in this way you can find the sum of two vectors. Now I will make the situation more complicated. Suppose this makes, okay, I will need to use a darker pen. Suppose this one is our vector a with magnitude a, and the another one is vector b with magnitude b, and it's making an angle theta 1 and angle theta 2 with x axis. Now you need to find the sum of a plus b. Let's see is the vector which gives a plus b. Here also we are doing the same thing. We need to resolve vector in two components. Let us resolve this vector in two components. I need to use a different color. Let's one component, this one is the x component, or this one is y components. This is a x components, this is a y component. Similarly this one is bx components, and the another one is by component. Now you need to calculate just the magnitude of bx and by. From here you can calculate ax is simply magnitude of a cos theta 1, as we did last time. Always remember the adjacent side which makes angle with the main vector becomes cos, the another one is sine theta 1. Similarly bx is b cos theta 2, and by is b sine theta 2. Okay, now we supposed c is the vector with magnitude. C is a plus b. Now we can find out the x component of C simply adding x component of A and B. So it's AX plus BX, which gives A cos theta 1 plus B cos theta 2. And the y components, AY plus y component of B, so which is A sin theta 1 plus B cos, sorry, it's not a cos, B sin theta 2. Now the magnitude of C is equals to square root of cx squared plus cy squared. So you can find out the magnitude, and to find out the angle between A and B, you again need to draw to find out the angle. You again need to draw this vector. Okay, I will try to redraw this vector so it's make clear how to find the angle. Okay, so this one is one vector, this one is another vector, this one is making angle theta 1, this one is making angle theta 2. If I join this vector, this one is the x component. Okay, let me erase this one. This one is the x component, ax. From here I'm going to draw the vector b. This one is the b, vector b. So again, this one is the x component of vector, this one is the x component of vector, so I can write vector bx. I'm going to just find out the direction. This one is theta 2, so I'm trying to find the direction. So the resultant vector is okay, this one is y component, and even I do not need to add that component. This one is the y component. Yeah, here you need to use parallelogram law. So let me make it more clear how to find the direction within a cell. Okay, so okay, I need to redraw this one. Yeah, it's not a correct way to find the direction. I need to redraw. Okay, let me redraw it one. So let me draw first the vector A. This one is angle theta 1, and this one is vector, yeah, this is angle theta 2. This one is vector B, Yeah, this one is the correct way. So this will be your resultant vector C. This one is the vector C, and we need to figure out this one, this angle suppose phi. So to find this angle, I will again, this one is the x component, oh sorry, that one is the x component of A, this one is x component of A, and from here to here, or from, you can say, this one to this one is x component of B, and this one is the x component of, this one is the x component of A, sorry, this one is y component of A, this one is the y component of B. Okay, now you can see this right angle triangle RST, this right angle triangle RST, you can simply, you can write tan phi, this one is this divided by this quantity. So you can say AY plus BY divided by AX plus BX. Now you can replace those values from previous calculations, and then you can just take inverse AY plus BY and AX plus BX. This gives the direction with x-axis. So this is ends of addition of two vectors. Similarly, you can add more than two vectors. You need to just x component and y component. Find out x component and y component. Just add x component to x component, y component to y component, and take square root of x component plus y component to get the magnitude, and find the angle using this geometry. You can draw this geometry anytime, so that you do not need to remember the formula, so that you do not need to remember any formula.